who is an MD, PhD. He's a research scientist at Loma Linda University. He's a professor of microbiology and immunology. He's particularly involved in the field of psychoneuroimmunology. In other words, how does the nervous system control the immune system, and what does your thinking have to do with it? Now, the reason why this is included on Thingo is because it is the easiest, clearest overview I've ever seen on how the immune system works. But there's a caveat here. This little piece was published in a Christian magazine, and it's written from a Christian perspective. So if that's going to leave you out, don't look at it. But if it's useful, okay, which is the explanation's useful, which is why it's up there. All right. I'll just start up there. So this blind here. Sure. All right. When I went to nursing school, back when dinosaurs walked the earth, you never had a specific chapter in anatomy and physiology for the immune system. Okay. Sometimes it was incorporated with the lymphatic system, but even then, they tended to just dump both of them into the blood. The reason for that was people didn't really understand a whole lot about how the immune system actually worked. Okay? And then we hit the AIDS epidemic. Okay? And all of a sudden, research money poured in to how the immune system works. Okay? We're going to see probably next time, or next time we lecture on the immune system, we're going to see that HIV, the HIV virus, takes down huge portions of the immune system. Okay? And initially, it wasn't understood how HIV was doing that, okay, because we didn't understand exactly how that portion of the immune system worked anyway. Okay? So there's been an explosion of research and understanding into how the immune system works. So when I went to medical school, I didn't really understand all that much about how the immune system worked, and neither did anybody else. And so the immunology that we had in med school was very confusing. Okay? And then when I landed teaching this, I'm going, oh great, I have to teach it now. Okay, so I actually had to sit there and take it apart. Okay, and actually, there are a few things that if you understand, it makes the whole thing not so bad. Okay. Now, it's probably also a fortuitous time to be teaching the immune system because our country has been at war for a number of years here, and everybody is pretty familiar, or has gotten pretty familiar with a lot of the terminology we use for fighting wars. Okay. The immune system functions, in a large sense, a lot like a military does. Okay? If you can more or less understand how a military does what it does, you can understand how the immune system is doing what it does. Okay? Now, sometimes I wear my camo jacket. They say all good teaching is theater, so sometimes I wear my camo jacket. I forgot it today. Anyway. Okay. So anyway, talking about the immune system as armed forces or as the military. Now, our military is divided up into a number of branches, correct? Okay, what are some of them? Army, Navy, Air Force, Marines,
Coast Guard,
National Guard, and then subgroups within that, the Special Forces. Okay. Why is the military divided up into those different branches?
To specialize.
More or less specialized. What does the Navy do?
Water.
Both stuff. Okay. Which will get you killed in the Navy. It's a ship. So, okay. Each branch of the military has an an area that it specializes in, that it is the best in. It doesn't mean that other branches of the military don't have boats or planes or whatever. It's just that that particular branch is the specialist in that use. Okay? Your immune system also is divided up into various branches that have a specific focus, or that have an area that it's focused on. Now, if we have invaders that invade the United States from wherever, is the Army going to sit back and go, nah, that's not me, I think I'm going to wait for the Air Force to handle it? No. Okay. Armed forces in general will take on any threat. Okay? They'll do the best they can with any threat. Okay? Your immune system also does the same sort of thing. Okay? The first part of the immune system that we're going to talk about is called the non-specific immune system. The non-specific immune system takes on any threat that comes down the pike. Okay? And there are various components of the non-specific immune system, like there are various components of the armed forces. Okay? However, we're going to spend an awful lot of time as well talking about the specific immune system. The specific immune system also has several different components, but the specific immune system works an awful lot more like the special forces. Okay? Now, tell me, what's the difference between the general armed forces and the special forces?
Specific training, yeah.
Okay, they usually have a whole lot more specific training. Okay, what else?
They have a lot more intensive skills, just in general, and they only get pulled out in very specific circumstances.
Exactly. They have very specific skills, okay, and they have very specific missions, okay? Very specific skills and very specific missions, okay? So if you send a special forces team in to take out Osama bin Laden, for example, are they going to get back there and go, well, you know, I like this bridge here, so I think I'm going to blow up this bridge? No. They've got a specific focus. They go do that, okay? They don't mess around with whatever else is going on around them. They've got a specific thing that they're after, okay? That's the specific immune system, okay? And just like the special forces have specific skills and specific training that's a little different than the other armed forces, that's the way it is with the specific immune system as well. Okay? The specific immune system is especially what gets impacted with HIV, with AIDS. Now, if you are defending anything, do you rely totally on soldiers or sailors? No. What else do you have to defend you?
Intelligence.
Huh?
Intelligence.
Okay. Intelligence.
Any sort of
Very, very basic.
weapons.
Fences, okay, barbed wire, barriers, things like that. Okay. So with your body, the very first line of defense that you have against invaders are barriers. Okay? Your skin, for example, is a barrier. Okay? The mucosa that you have is a barrier. Now, when something breaches the barrier, okay, it usually sets off alarms, correct?
Mm-hmm.
If somebody gets past the perimeter, okay, it causes things to happen, right? Okay. So if something breaches the barriers to you, okay, stuff begins to happen. Okay, you have a second line of response, okay, or a second line of defense. Now, this second line of defense involves a bunch of different stuff. Okay. Most of the second line of defense is organized around a process called inflammation or the inflammatory reaction. Most of the second line of response is organized around the inflammatory response or the inflammatory reaction. Now, how does the Army or the Navy or whatever communicate? Walkie-talkies. Okay. What else? Cell phones. What else? Computers. What else? Morse signals, Morse code, okay, flashlights, flags, okay, runners, sometimes they use runners, okay, sat phones, I mean, all kinds of funky stuff, right? Okay. Now, if the armed forces have multiple ways to communicate and thereby control the response, you would expect your body to also have ways to communicate and to control and direct the immune response. And your body does. Okay, but remember, your body doesn't yell. Your body doesn't go, hey, you, do this. Your body communicates in many instances with chemicals. And the immune system is no exception. Now, this one thing right here would have made an awful lot more sense out of my whole schooling if I had understood this. There are many different chemicals involved in different parts of the immune system. And they have names like this. Okay? Cytokines, interleukins. Lymphokines, leukotrienes, interferons, prostaglandins, bradykinins, pyrogens, histamines, that's probably a good representative list. Now, it would be bad enough if you were sitting there trying to remember what each of these different things did. But the thing that's even worse is that, tissue necrosis factors. Okay, and this just goes on and on and on. It'd be bad enough if you were trying to remember what all of these did, what each of them did. Then you get into several different types. For example, there's an interferon alpha and there's an interferon beta. Okay? There are a bunch of different interleukins. There's interleukin 1 and interleukin 2 and interleukin 3 and on and on. Okay? There are various leukotrienes. Now, also, each of these communicates with other molecules differently. So interferon alpha may, I'm just making this up here, but interferon alpha may communicate with leukotriene gamma. or interleukin-3. Okay. In other words, it becomes very confusing trying to follow the wiring down. Okay. But if, when you see one of these words, you think, okay, that's one of those communication means. Okay. It's a way of sending orders. It's a way of sending intelligence. It's a way of the immune system controlling itself. It's the way that the immune system produces a coherent response, okay, using a blizzard of chemicals, okay, and these are just some of them, okay. Now, can I erase this yet? Because I need the board. I need the last three. So when you look at these and you run into names like these, if you think, oh, okay, that is one of those chemicals that is controlling something, that is providing instructions for the immune system, then it makes it a little easier. Okay, everybody got it? Okay, so we said, let's back up and mention where we're at here. We said that you have two overall categories of immune system. You have the nonspecific immune system. You have the specific immune system. The specific immune system we're going to talk about next time. Today we're talking about nonspecific immune system. The nonspecific immune system has several components. You have your first line of defense. Your first line of defense tends to be your barriers. Okay. Skin, mucous membranes, and the secretions that your skin and your mucous membranes come up with. You have a second line of defense. Your second line of defense tends to be organized around the inflammatory response. And the chemicals which run the whole show, okay, there's a whole list of them. Okay. All right, so let's move on and look at the inflammatory response here. Now, actually, let's look at some of this first. Physical barriers. Your skin and your mucous membranes are stratified squamous epithelial tissue. They are layers of cells. So to get past the barrier, whatever pathogen or whatever bad guy has to dissolve its way in through these tightly packed cells. And that's the case both with the skin and the mucous membranes. The skin and the mucous membranes do not make it easy for the pathogen. The skin has secretions that are coming out from the sweat glands and from the sebaceous glands. Some of the components of sweat make it hard for certain types of bacteria to grow. Okay? Sweat is very salty, for example, and some bacteria don't like that amount of salt. Okay? Some of the fatty acids that are contained in the secretions are toxic for certain types of bacteria. With your mucous membranes, you have the same thing, but you also have mucus. Mucus tends to trap and hold invaders. And in the case of mucosa that's ciliated, the cilia will move that mucus to a place where it's easy to get rid of. Mucous membranes often also have secretions. Some of those secretions contain antibodies. Some of those secretions contain lysozyme. Tears, for example, contain both lysozyme and IgA, which is an antibody. Many of the intestinal secretions, many of the salivary secretions contain lysozymes and contain antibodies. Okay. So you not only have the physical barrier, you also have the secretions. Now, supposing something gets past your first line of defense, something gets past your first line of defense and starts chomping away on body tissues. As we said, tissues don't just sit there and take it, they scream and yell. Okay? And the way that they scream and yell is by releasing chemicals. Okay? So when there's any kind of tissue damage, whether it's from an invader or whether it's from the tissue being torn apart, the damaged cells release chemicals. Some of the chemicals that are released are things like histamine, prostaglandins, and heparin. Now, for the moment here, two that I want to direct your attention to are prostaglandins and histamine. Histamine causes blood vessels to dilate, and it causes blood vessels to leak. That's what increased permeability means. Leak even more. So if you dilate blood vessels, are you going to get more blood flow to the area or less?
More.
More. Okay, if you dilate them, you're going to get more. Okay, if they leak more, are you going to get more fluid in the tissue spaces or less?
More.
More. Okay, so if you have more blood, okay, it is going to be redder because blood is red, right? If you have more blood, it's also going to be warmer because blood carries heat, correct?
Mm-hmm.
If you have more blood and more fluid is leaking into the tissues, it will make the tissues swollen, correct? Okay. When tissues swell, they stretch, okay, and they pull on stretch receptors and they pull on free nerve endings, and that causes them to hurt. Okay. In addition to the fact that the tissue damage itself produces prostaglandins, which enhance pain. Okay. So your response here, your body's response to the damage, produces redness, heat, swelling, and pain. Okay. Those are the 4 cardinal signs of inflammation. Okay. Redness or rubor, heat or calor, swelling or tumor, and pain or dolor. Okay, those are the Latin words. They're very similar to the Spanish words. Hyrospilling. Okay? Now, your body does the inflammatory response when it gets damaged. Now, if you bring in a bunch of extra blood, what do you bring along with it? Oxygen and white blood cells. Okay. You bring fluids to help wash away whatever toxins or junk is in the area. You bring oxygen in there to kill things off. You bring white blood cells in there to kill things off and to clean up the damage. Okay? So is the inflammatory response a good thing or a bad thing? In general, it's a good thing. Okay? It's how your body responds to an invasion. Does it tear up a bunch of things? Yes. Okay. What's the purpose of an army?
Destroy, to win.
It's supposed to be to keep us safe.
Okay. All right. That's true. To keep us safe and to win. But how do they do that?
By destroying other things.
By killing people and breaking things. Okay. That's what military does. That's what they're specialized to do. Kill people and break things. Okay, so here you've got your military responding, okay, and it's killing off the bad guys, okay, and in the process, stuff gets broken. Okay? So, is the inflammatory response a good thing or a bad thing? It's a good thing. Can it get out of hand?
Yes.
Yes. Okay. So, prostaglandins cause pain. They also cause fever. Prostaglandins are one type of pyrogen. Now, you get heat in the area where you've got your inflammatory response going on because you've got increased blood flow there. However, your hypothalamus, one of the things that the hypothalamus does is it sets the thermostat for your whole body. What gives instructions to the hypothalamus on where your thermostat should be set? Okay. Ordinarily, your hypothalamus just does what it's supposed to do. Okay. It keeps your temperature at the correct level. When you have pyrogens, though, circulating in the blood, pyrogens reset the hypothalamus, and all of a sudden your body goes, oops, it's too cold in here. We need to turn up the heat. And so you shake and you shiver and you start burning glucose, and what does your body temperature do? Go up, okay? An increased temperature is part of the inflammatory response, or may be part of the inflammatory response, and it has a specific protective effect. And we're going to talk about that in another slide. Okay. So, these chemicals, okay, histamine causes dilation and all this stuff. Okay. You also may have clot formation if you have damaged tissue. Okay. But the other thing that these chemicals do is they call in the other white blood cells. They call in the other white blood cells, and they activate specific defenses. Okay. Remember, we said we're not going to talk about specific defenses until next time. Okay. Hopefully, if all goes well, the bad guys get clobbered, and then the damage gets repaired. Okay. So, with our inflammatory response, blood flow is increased, phagocytes are activated, capillary permeability increases, complement's activated. We're going to come back and talk about what these things are in a minute. Clotting may occur, okay, regional temperature is increased, and your defenses are activated. Okay. Part of the inflammatory response here, part of the chemicals that are released here may be pyrogens. Okay. Pyrogens cause your body temperature to rise above normal. Okay, what's normal in degrees Fahrenheit? 98.6 or thereabout. What is normal in centigrade, Celsius? 37. Okay, or thereabouts. Okay. Okay. of the cells that is called in when you have an inflammatory response, one of the cells that is called in are your phagocytes. Now, phagocytes are cells like macrophages, monocytes, Kupffer cells, neutrophils, eosinophils. Now, you already know what macrophages are. You already know that monocytes are macrophages that are circulating in the blood. And then when they get out into the tissue spaces, they change names. And instead of being called monocytes, now they're called macrophages. You already know what neutrophils are. Neutrophils are specialized for taking out bacteria. You already know what eosinophils are. Eosinophils are specialized for taking out parasites, and they also are active during allergic reactions. Kupffer cells are specific cells that are found in the liver. And they also are macrophages. Now, we think of white blood cells sometimes as just bopping along, flowing through the body like red blood cells do. And that's not actually the way white blood cells travel. White blood cells don't just flow along with the red blood cells. White blood cells do something that's called pavementing or margination. They actually crawl their way along the walls. So, if you are taking a sample of blood, you're going to stick a needle in here, and the blood that you pull out isn't going to contain very many white blood cells, right? Okay, your white blood count, a normal white blood count, is way, way fewer than a red blood count, okay? A red blood cell count. The reason for that is you're just pulling out the white blood cells that happen to be flowing. Most of them are not flowing. Most of them are pavementing or marginating. Okay?
Why do they do that?
We'll get to that in a second. Okay. Now, sometimes when a person has an increased amount of stress, say they run a marathon or something like that, they'll have a transient bump in their white count. The reason for that is these white blood cells demarginate. They get knocked off the walls, and now they're circulating, so their white count rises. Does that mean they have an infection?
No.
No, that just means that now you can count more of the white blood cells because they're not stuck on the walls. Okay. Now, what are these white blood cells looking for as they're pavementing along? Okay, they are looking for a signal. Okay. Remember, we said that what happens when you have damage, when you have invaders out here, is you have a bunch of chemicals released. Those chemicals call in other components of the immune system. So your white blood cells marginate along here until they pick up a signal, okay, and then they slip out of the cracks here in your capillary and move towards where the chemicals are. Okay. The process of slipping out of the capillary into the tissue spaces is called diapedesis. Okay? They crawl out. Diapedesis. The process of moving towards where the chemicals are is called positive chemotaxis. Negative chemotaxis would be moving away. Positive chemotaxis, you're moving towards the chemicals. So one of the things that these inflammatory chemicals do is call in the phagocytes.
What did you say that word was? Where they're going to?
Chemotaxis. Now remember, what we're talking about here is phagocytes. Okay. In particular, to do any good, well, first of all, what does a phagocyte do? It eats things. Okay? Phagocytosis is eating something, okay? Or engulfing something. So phagocytes are cells that are specialized in phagocytosis. Now, it doesn't do any good to engulf something if the, whatever it is, whatever the something is, whatever the little invader is, if the invader just sits up shop inside the cell. Right? You haven't gotten rid of it. Okay? So during phagocytosis, okay, your invader is engulfed, and then your invader is killed off somehow. Okay? Now there's several ways that this can happen. The little vesicle here containing your invader, your little phagosome here, can be incorporated with a lysosome. A lysosome, you remember, contains digestive enzymes. What is that? What are those digestive enzymes going to do to your invader?
Tear it up.
Digest it, tear it apart, dissolve it. Okay. You can also incorporate peroxisomes. What do peroxisomes contain? Hydrogen peroxide, which is an oxygen compound. Okay. There are also little vesicles that contain hypochloric acid. What's hypochloric acid? Or hypochlorate? Bleach. Okay. So, whatever way these things are killed off, okay, sometimes this killing is using an oxygen compound, and when it's using an oxygen compound, it's called a respiratory burst. A respiratory burst. Now, the macrophage can do several things with the debris. Okay. It can hold on to the debris. It can use the debris as intelligence to plan the next part of the response. Okay. Or it can just dump the debris and let your kidneys remove it. Now, as we said, this process is only effective at getting rid of an invader if the invader actually gets killed off. There are some diseases, and tuberculosis is one of them, where the body is not able to kill the invader. The invader just has its nice little condo here inside the phagocyte. Okay? And it can live there, okay, longer than you can live. And when we get to micro, when we talk about organisms that cause diseases, all of the organisms that cause diseases have a way of getting around the immune system, at least initially. Otherwise, they wouldn't cause a disease. Okay? And with tuberculosis, it gets around the immune system by not getting itself killed when it's swallowed by a macrophage. Now, there are children that are born without the ability to do a respiratory burst. Okay? What do you suppose happens to them from the time they're babies? they have repeated infections, especially with bacteria, because macrophages and neutrophils are designed to take out bacteria. Yes, Margo?
So does it let it go?
No. Well, it depends on the disease.
Like, is one phagocyte gonna sit there and have like 20 of these things like stuck inside of it, or does it let them go even though it's not dead inside?
It depends on the disease. With tuberculosis, they tend to just sit there and live happily ever after. With some other diseases, like listeria, okay, they travel from one phagocyte to the next, or from one body cell to the next.
Does it prevent them from splitting and multiplying?
No. Okay. But does it prevent them from being seen by the rest of the immune system?
Yeah.
Yes. Okay, that's a problem. Okay, now, for our macrophage to swallow our invader here, our macrophage needs to be able to get a hold of it. Okay? Have you ever seen like a county fair or something where they chase pigs? Okay. What do they sometimes do to the pigs to make them extra hard to catch? Yeah, they grease them. Okay. And that's really hard to catch a greased pig. Okay. A lot of these invaders running around are like greased pigs. They're very hard for the phagocyte to grab onto. One of the things that antibodies do is coat the pig so that it's easier to get a hold of. Okay. One of the things that complement proteins do, we're going to talk about in a minute, they coat the pig here so that they're easier to be swallowed. That process of coating the pig out here is called opsonization. All right, so back to our general picture here. One of the things that the inflammatory response does is call in other immune system cells, in particular phagocytes. Phagocytes remove debris and they remove pathogens. Okay? You have macrophages that are fixed. In other words, they stay at that spot. They own that corner. Okay? You have macrophages that roam around. Those are free macrophages. Monocytes are macrophages that are cruising in the bloodstream until they get to a place where they're needed, and then they diapedese or crawl out and become a macrophage. Neutrophils are specialized for engulfing or phagocytizing bacteria. Eosinophils are specialized for phagocytizing parasites. Okay, everybody with me up to this point? Okay, let's take a break and we'll come back and finish it. Sonny, are you all right? Okay.
I have a question about what you said. So babies who are born without the ability to have a